Bismillah ar-Rahman ar-Rahim. This is an exercise about sequence defined recursively, which is defined by a recursive formula. So consider the sequence which is defined by the formula x index n is equal to the square root of 2 plus x index n minus 1. And the first term, x1 is equal to alpha, alpha is greater than or equal to 0. This sequence, is it convergent or not? If it is convergent, we will show that it has a limit and we will calculate it. So way to give a solution, there is many ways. For example, this one. So we set f of x equal to the square root of 2 plus x. So we associate this sequence with the function f. The domain of definition is minus 2 plus infinity. It is clear, trivial. And the image, the rank of f of d is a subset of d. So if we calculate the derivative, we will find 1 over 2 square root of 2 plus x, which is strictly positive. This means that f is increasing. F is increasing, but to check the sense of variation of the sequence, we have to examine the sign of the two first terms. I mean, u index 2 minus u index 1. After simple calculation, we find u index 2 minus u index 1 is equal to this quotient, 2 minus alpha times 1 plus alpha over square root of 2 plus alpha plus alpha. So here we guess, so we remark that if alpha is equal to 2, the difference is equal to 0, which means that the sequence is constant. If alpha is less than 2, this means that the difference is positive, which means that the sequence is non-decreasing. If alpha is greater than 2, so the difference is negative, which means that the sequence is non-increasing. So we will answer just the second case. The first case is trivial, and the third case is symmetrically the same with B, this case. So here we prove that by induction, we prove that the sequence xn is less than or is less than 2 for all n. So to do this, we will proceed by induction. The statement for n equal to 1 is true. Why? Because x1 equal to alpha. And in the assumption, so discussion, we set before that alpha is less than or is less than 2. So this is true. We suppose that the statement is true to rank n, which means that we suppose that the sequence xn is less than 2, and we show that it's still true, so for xn plus 1. So as Sn is less than 2, if we add plus 2, if we add 2 to the two sides of the inequality, we will get xn plus 2 less than 2 plus 2, which means that xn plus 2 less than 4. And if we take the square root of xn plus 2 is less than 2, which means that the statement is true for all n. This means that the sequence is increasing and bounded above. It is bounded by 2. We have a theorem or a corollary which says that if we have a sequence which is monotone and bounded, this sequence is convergent. This case, we have a sequence which is increasing and bounded above. So it's converts to a solution of the equation L equal to f of L. The solution of L equal to f of L, we have two solution, -1 which is rejected. Why it is rejected? Because our sequence is increasing and it starts from alpha. Alpha is greater than or equal to 0. So it remains the second solution, which is 2, and we finish by saying that this sequence is convergent and it's converged to 2. We can do the same thing with the case alpha greater than 2, but in this case the sequence will be non-decreasing, and it will be non-decreasing and it converges to 2, but it came from above. In this case, in the case B, it comes from below. Thank you. See you next time.